Guidance for inspectors, on-stream and off-stream inspection of plate heat exchangers, PHE, essential inspection procedures for reliable heat exchanger operation. Title and technical context, purpose of the inspection guidance, scope and applicability, applicable codes and standards, plate heat exchanger overview, main components of a PHE, PHE as a pressure vessel under API 510, damage mechanisms and common failures, inspection philosophy, on-stream versus off-stream, professional role of the inspector. This slide introduces the engineering-focused guidance for inspectors responsible for the mechanical integrity of plate heat exchangers, PHEs. The presentation is intended for use by authorized inspectors, inspection engineers, and integrity professionals working in refineries, petrochemical plants, and other process facilities. The scope is aligned with API 510 for pressure vessel inspection, API 572 for practical inspection methodologies, and relevant ASME construction and design principles. Plate heat exchangers, while compact and efficient, operate under pressure and temperature conditions that require disciplined inspection practices to ensure continued safe operation. This guidance emphasizes professional judgment, code compliance, and practical field execution. Inspectors are expected to understand the design basis, operating envelopes, and service conditions of PHEs, and to integrate inspection findings with risk-based decision-making. The title slide establishes that the presentation is not introductory training, but rather a professional reference suitable for experienced inspectors and engineers who are accountable for equipment integrity and regulatory compliance. The purpose of this guidance is to provide inspectors with a structured and technically sound approach to performing both on-stream and off-stream inspections of plate heat exchangers. From an engineering perspective, the objective is to ensure pressure integrity, prevent loss of containment, and detect active or potential damage mechanisms before they result in failure. This slide emphasizes alignment with API 510 requirements for inspection responsibility, documentation, and interval determination, while also leveraging the practical inspection techniques described in API 572. The guidance supports consistent inspection execution across sites and inspectors, reducing subjectivity and missed damage. It also aims to improve communication between inspectors, operations, maintenance, and corrosion engineers by providing a common technical framework. Ultimately, the purpose is to enhance safety, reliability, and regulatory compliance while recognizing that plate heat exchangers often experience unique degradation modes compared to shell and tube exchangers. This slide defines the scope and limitations of the inspection guidance. The content applies primarily to gasket and brazed plate heat exchangers that operate as pressure-containing equipment in process and utility services. The focus is on mechanical integrity, including plates, gaskets, frames, and pressure boundaries, rather than thermal performance optimization. The guidance does not replace original equipment manufacturer, OEM, manuals, design specifications, or site-specific procedures, which always take precedence where more restrictive. Inspectors are reminded that certain PHE designs may have limitations on disassembly, non-destructive examination, or repair options. The applicability also depends on jurisdictional and company requirements, and the owner/user retains ultimate responsibility for inspection scope, acceptance criteria, and continued operation decisions in accordance with API 510. This slide summarizes the primary codes and standards that form the technical basis for PHE inspection. API 510 establishes the requirements for inspection, rating, repair, and alteration of pressure vessels, including those of unconventional design such as plate heat exchangers. API 572 provides detailed guidance on inspection practices, visual examination techniques, and identification of damage mechanisms that are directly applicable to PHEs. ASME Section 8 provides the original construction rules, including design pressures, temperatures, and allowable stresses that underpin MAWP calculations. ASME PCC2 may be referenced for repair methodologies when plate replacement or temporary repairs are considered. Inspectors must understand how these documents interact and apply professional judgment when adapting general pressure vessel requirements to the specific design features of PHEs. This slide provides a technical overview of plate heat exchangers from an inspection standpoint. PHEs consist of a series of thin, corrugated metal plates that create alternating hot and cold channels, resulting in high turbulence and efficient heat transfer. Their compact design leads to lower fluid inventory but higher sensitivity to fouling, corrosion, and gasket degradation. Common services include cooling water, process streams, heat recovery, and utility systems. Inspectors should recognize that high turbulence zones, flow distribution areas, and gasket grooves are often the most susceptible to damage. Understanding the basic operating principle and flow paths is essential for identifying likely damage locations and interpreting inspection findings accurately. This slide describes the main components that require inspection focus. These include the fixed frame plate, movable pressure plate, heat transfer plates, gaskets or brazed joints, carrying bars, and tie bolts. From a mechanical integrity perspective, each component has distinct failure modes and inspection considerations. Plates may suffer from thinning, pitting, or cracking, while gaskets are prone to chemical attack, hardening, or extrusion. Frame components and bolts must maintain structural alignment and clamping force to ensure gasket sealing. Inspectors should understand how these components interact as a system, since degradation in one area, such as bolt relaxation, can lead to leakage or plate movement even if plates themselves remain intact. This slide explains how plate heat exchangers are treated under API 510 when they contain pressure. Even though PHEs differ from traditional shell and tube vessels, they are still subject to inspection requirements when operating above atmospheric pressure. Inspectors must ensure that design data, including MAWP, design temperature, materials of construction, and corrosion allowances, are available and understood. API 510 assigns inspection responsibility to the owner/user and requires that inspection intervals, methods, and acceptance criteria be established. This slide emphasizes that inspectors should not exclude PHEs from inspection programs simply due to their compact or modular design, and that pressure integrity remains the primary concern. This slide consolidates typical damage mechanisms and failure modes observed in plate heat exchangers, as described in API 572 and industry experience. Common mechanisms include general corrosion, erosion or erosion corrosion in high-velocity zones, pitting and crevice corrosion under gaskets, and stress corrosion cracking depending on material and service. Gasket degradation due to temperature, chemical exposure, or aging is a frequent cause of leakage. Typical failures include plate perforation leading to cross-contamination, repeated gasket leaks, plate deformation, and frame misalignment. Inspectors should correlate observed damage with operating conditions and process chemistry to determine root causes and appropriate mitigation. This slide outlines the inspection philosophy for plate heat exchangers, distinguishing between on-stream and off-stream inspection activities. On-stream inspection focuses on early detection of abnormal conditions while the equipment remains in service, using visual checks, operational data, and process indicators. Off-stream inspection, conducted during shutdowns, allows detailed internal examination, thickness measurement, and gasket assessment. A risk-based approach is encouraged, where inspection effort and frequency are aligned with the likelihood and consequence of failure. Inspectors should integrate both approaches to form a complete integrity picture, recognizing that many PHE failures provide early warning signs if properly monitored. This final slide emphasizes the professional role and accountability of the inspector in managing PHE integrity. Inspectors are expected to apply independent technical judgment, ensure compliance with applicable codes, and clearly communicate risks and recommendations to the owner/user. Effective inspection requires coordination with operations, maintenance, and corrosion specialists, as well as thorough documentation of findings and decisions. The slide reinforces that codes and standards provide a framework, but do not replace engineering judgment or responsibility. By applying disciplined inspection practices to plate heat exchangers, inspectors contribute directly to safe operation, environmental protection, and asset reliability.